In our introductory module on sustainable energy, we explored different possible options of it, and that time we realized that increasing energy efficiency is possible, one of the best possible option. Say 25 years back, we were also not that much concerned about energy conservation and energy management, but presently with the realizations of limited resources, we have realized that energy conservation and increasing energy efficiency through proper energy management is undoubtedly the best possible sustainable energy option. Today, in this discussion, we will have an overview of the different possible options of energy conservation and energy management. I must admit that it will be a just brief overview. We will not be able to explore the sector specific energy conservation principles, but we will make a general overview of the possible energy conservation's scopes and options. When we discuss about the energy conservation principles, the first thing comes into our mind is the good housekeeping. These are low cost or even no cost measures we can take to increase the energy efficiency. The basic good housekeeping example can be switching off the light when we are not using it. Maybe in industrial applications, this energy saving through good housekeeping may be substantial in different applications. So, whenever possible, this good housekeeping options should be given a priority, and this is basically in most of the cases this will depend on human habit and consciousness. But presently industry is very much conscious about this energy saving potential through good housekeeping. We can have the energy efficiency increase by energy cascading and the corresponding total energy concept. Previously, the idea of energy use was one particular unit will be dedicated for one particular utility, say for power plant, say for heating another heating boiler. But people started realizing that when successfully we can combine more than one utility in a single plant, overall efficiency increases. And this concept of combining more than one utility in a single unit lead to many applications. We will come into that in detail later. Then energy storage and peak load management is another important issue. We know that over the day, even over the season of the year, the demand of electricity varies, and this variation always, if we cannot match it with the supply, then obviously we will have a lot of problem. Either the deficiency in supply will lead to power cut, or excess of power, we have to run the system in a lower efficiency. So, matching of this demand and supply is only possible efficiently through energy storage, and managing the peak load means if by some measures, maybe by changing the human behavior, if we can manage our peak load demand to be to as close as possible as average demand, we can make the system better efficient. That can be another good option for the energy conservation. Then comes the waste heat recovery. It's a big area of energy conservation. The concept of waste heat recovery is the heat that is otherwise wasted, if we can utilize it, then undoubtedly overall energy efficiency will be higher. This is another big area of engineering applications, and we will have little bit more exposure of different possible waste heat recovery at the later part of this particular module. Then incineration of waste materials. I must say, this is not only an energy conservation issue, but it's an issue related to the environmental pollution too. One of the most important issue of sustainable options is recycling waste, and the waste material, if we can use for the energy generation, then it serves two purposes. It recycles the waste and also compensates some of the energy that would have been otherwise generated from using fossil fuels. So, incineration of waste materials can also be considered as one of the possible options of the energy conservation. Alternative sources of energy is also another important area in energy conservation and overall energy management. The more we can use alternative sources of energy, obviously the less is expected to be of the environmental degradation and impact. So, the exploring more and more alternative sources of energy will not only be, reduce the load on the conventional fossil fuel, but also it will help to protect our environment. And finally, I must say, apart from these, sector-specific energy conservation is a big area. Whenever we discuss about the cement industry energy conservation, then specific principles of that particular sector will be different from paper industry energy conservation principles. And each of these sectors for energy conservation needs domain knowledge, and so obviously in this small module and discussion, I will not include those sector-specific energy conservation principles. I will mostly concentrate on general aspects and general principles of energy conservation. Now, if we start with the energy cascading and the total energy concept, then the first example of that particular energy cascading can be given as the combined power cycle. Previously, gas turbine and steam turbine power plant were two separate entities, and both of these power plants were useful for the power supply. But later on, people realized that these two technologies can be easily combined, because the gas turbine is rejecting substantial amount of heat, and that heat can be used in a bottoming steam turbine power plant to generate power in a better efficient way. Then came the concept of the cogeneration, where the utility heating and the power generation was combined. Recently people have started thinking, why not the cooling, which is a general requirement in most of the industrial applications, we combine with the power and utility heat, that means the cogeneration, that means that comes the concept of trigeneration. And very recently people have started thinking even integrating more utilities like supplying drinking water or other utilities in a single unit in a more efficient way, and that's called the general name as polygeneration. The polygeneration in detail will be taken care of, because that is considered to be one of the very efficient option, sustainable option for the future, and obviously we will discuss it in a full module later. Giving the example of the combined cycle power plant, all of us know the basic principles of a heat engine, where the efficiency is expressed as the reversible cycle efficiency can be expressed as 1 minus T2 by T1, where T2 is the temperature of heat rejection and T1 is the temperature of heat receipt. Then if we combine one heat engine with another in a series, then interestingly a small, a bit numerical calculations can show that the final efficiency, overall combined cycle power plant efficiency, is more than the individual efficiencies of those engines which we combine. That means it's always preferred to run two heat engines together in series rather than running them separately. So it's a good way of increasing the energy efficiency and leading to the energy conservation. Then comes the cogeneration. We know that in cogeneration we are combining both power output and the utility heat, so that the waste heat from the heat engine that can be reduced, and overall efficiency, that means as the utility is increasing from the same input, the overall performance or efficiency increases. Then comes the trigeneration, where some of the power can be utilized for the refrigeration purpose, where we get the cooling effect. So the overall performance of the integrated unit, which combines both power, utility heat and the cooling effect, improves even more. Then comes the concept of polygeneration, which is basically a generalization of these previous concepts, where many utilities will be combined together, and if we put it into more detail, the output of one of the unit may be thus or wholly or partly may be the input to the next unit, and the overall input and output relation, in many cases it may not be very simple, and number of inputs and outputs are completely, there is no restrictions on these. So the inputs may be locally available resources, so that it can be even more sustainable using so-called locally available unused resources. Then if we consider the performance criteria of this multi-utility units, the problem lies in defining how much importance we could give on different utilities. That means whenever we discuss about the cogeneration, as an example I can discuss on the cogeneration, then we can find out that the power and utility heat are the two utility outputs. But interestingly, the power and utility heat, they may not be of same quality thermodynamically. So though there was initially a particular parameter which is called energy utilization factor, there the power and utility heat was thought, rather put into the same category in the numerator. Later on people realized this is not a good definition of measuring the performance. Then people defined one definition which is called value weighted energy utilization factor, where the economic concept came into the picture. Economically, 1 unit of electricity is always better than 1 unit of utility heat. In market price also that is reflected. So what is the concept of the value weighted energy utilization factor is, use the unit price of these utilities into the definition as shown here, where the thermodynamic quality difference between these two utilities are included in their economic price itself. Then there was another definitions in the form of fuel energy savings ratio, where the amount of fuel energy saved due to the integrations of more than one utility is included. So the better the efficient or rather better or efficient way of combining more than one utility will be reflected by more saving of fuel, and hence is the definition is such where we can measure how much better energy efficiency we are getting through fuel saving by this definition. Then come to the definitions of the energy storage. Energy storage, as I mentioned, that this energy storage requirement comes from the difference of the energy demand and the supply, and there are in the energy conversion chain, the conventional energy conversion chain, we use a fuel and then finally it delivers the electricity. Then during this conversion chain from the fuel up to the electricity, at each stage we have options for storing. For example, if we can make a better energy efficient system, then the fuel itself can be saved, and that's also energy storage option. And once we burn the fuel for the subsequent use in the in a heat engine to use, then there also the heat energy can be stored in different options, like it can be stored as the steam, by generating steam either in the saturated or superheated form. It can be used in the chemical storage form in the form of desiccant or mixture, so on. And when we use that heat in a heat engine to deliver the power, then that power itself, mechanical power, can itself be stored as different forms like flywheel. It can be stored in the form of pumped water storage, etc. Then that mechanical power can be converted to electricity, the most desired form of the energy use, and through the generator. And then finally, unused electricity can also be stored in a capacitance. It can be stored electrochemically. But I must mention, I have only mentioned the different possible options, but all these options are not suitable for different capacity and different conditions. So this is just a preliminary information for the students to have an idea of different possible options of storage at different part or stage of the energy conversion chain. But be very sure about it that all these energy storage principles are not equally good and they are not economically feasible also. But this is a big area of research that is needed with this energy conservation needs increasing. Then the waste heat recovery, the waste heat we define it in this way, this is the heat, otherwise it would have been wasted to the atmosphere. So if we can make it useful for economic purpose, then obviously it will be a waste heat recovery. Then a typical process plant for which the waste heat recovery can be applied, we have a fuel that is being used in the process plant, and we have some certain waste fuel and we have certain flue gas or drain liquid. Both flue gas and drain liquid may carry certain amount of heat, and the waste fuel may also be recovered. And then the modes of heat recovery can be either of these two. If there is a waste fuel, the standard practice or most convenient practice is to go for subsequent combustion, and then generated flue gas can be used for heat transfer, and then finally the exhaust will go out, and below which you cannot use the heat. And then alternately, if your heat is contained in either in the flue gas or in the drain liquid, then obviously you have to use a different type of heat exchanger to extract that heat. Then the different options of this waste heat recovery equipment, that means depending on the source and the fluid that will receive the heat, we have different possible convenient options. For gas to gas heat recovery, that means from the flue gas to another gas where we will use that recovered heat, the different possible options are heat pipe, rotating regenerator or heat wheel, it can be a run around coil, it can be a plate heat exchanger, it can be a convection or tubular recuperator, etc. So details of each of these equipment is not possible to explain, but we know that the different possible options are there. Then gas to liquid heat recovery equipment, we have some we can name as economizer, then waste heat boiler, then thermal and fluid heater, etc. Liquid to liquid heat recovery is mostly these are the heat exchangers. They can be shell and tube heat exchangers, they can be plate heat exchangers. Plate heat exchanger is basically used for low pressure and low temperature to heat exchange process. And then waste heat recovery from prime movers, already these examples lie in the gas turbine and the reciprocating heat engine, where substantial amount of heat recovery can be done. Any waste heat recovery must be supported by corresponding economics. In engineering applications, unless it is economically feasible or viable, we never accept that. The preliminary assessment of the waste heat recovery economics is done by two parameters. One is the payback period, another is the return of investment. Payback period indicates basically the time in years, that means how much years are necessary to recover the investment we do for the heat recovery equipment or for the entire installation and operation. And on the other hand, return of investment is basically the concept of any business, that means whatever we have invested in the form of money, then how much we are getting interest out of that. So these two parameters numerically look like something like this. But I must remind that these two are very preliminary assessment criteria. Actually, in real life assessment, we have to go into more detail, taking care of the time value of money, because whenever we invest some money, then the return of investment over time should be calculated on the basis taking the consideration of the time value of money also. So these two are basic definitions or starting definitions, but obviously we have to go into more detail for actual assessment of the waste heat recovery economics. Renewable energy is undoubtedly a very important area presently with respect to not only energy conservation but also with respect to the so-called environmental impact. The concept of renewable energy is, for a finite energy source, whenever we use it, finally the impact goes to the environment only, and obviously it depletes the limited resource of fuel. But for the renewable energy, we have that particular available energy in the environment whether we use it or not. So obviously when we use it through a device, then also the impact is not something additional to the environment. So obviously the renewable energy use is always preferred, not only from the energy conservation but also from the energy management and better environmental impact viewpoint. From the viewpoint of energy management, the important issue is how much is the energy conservation in different sectors. We have to have an idea which sector should be given highest priority for energy saving. Obviously, that will be reflected by the energy consumption. This picture shows the sector-wise energy consumption in India as published by the Bureau of Energy Efficiency, the highest energy efficiency authority in India. Then we can find out that energy intensive industries has the maximum amount of energy consumption. So undoubtedly, with respect to the energy management principle, we should have the highest priority in these. Then in transportation is another sector that comes next. In building and both residential and commercial, we can also have substantial energy saving potential. Then supply side management and demand side management, these two are interrelated, but always we can have substantial saving through this. In India specifically, agriculture sector has got lot of energy saving potential too. The energy management basically it is an integrated approach. We have to think about the energy conservation, we have to think about the renewable energy use, and we have to make a planning and awareness, and the people have to take part in that. So as if we can consider that the energy management is standing on three distinct pillars, and the overall integrated planning must be done not only with respect to energy conservation, but with respect to more use of renewable energy and also awareness and capacity building. Thank you.